All right, year 10, let's take a look at how to do this question. So we've got a pulley system, a 2 kg mass resting on top of the table, and then we also have a 3 kg mass hanging over a pulley. So we've got a pulley on the edge of the table, and the two objects are connected through a piece of string. So the question is telling us that once the 2 kg object is released from rest, it will accelerate at a rate of 4 meters per second squared. So if the top one accelerates at a rate of 4 meters per second squared, this object is also going to accelerate at the same rate. Right? That makes sense because the two objects are connected through a string. So if you release one, they are both going to accelerate at the same rate. Now, let's deal with the first question. Calculate the resultant force acting on the 2 kg object. That's pretty straightforward. So we have force is equals to mass times acceleration. The mass is 2 kg, the acceleration is 4 meters per second squared. So the resultant force acting on the object is going to be 8 newtons. Okay, that's all good. Now, calculate the upward force exerted by the cord on the 3 kg object. Now let's take a look at this diagram again. So they're talking about the upward force on the cord. And really, the force we're talking about here is just going to be the tension on the string. Since the two objects are connected through a string, they're going to be accelerating at the same rate. To simplify the situation, I can only consider this portion of the setup, just to make life easier. So now, let's take a look. Well, first of all, we have some acceleration, okay? Newton's second law is telling us that the larger the force, the greater the acceleration this object will experience. Okay, let's take a look. So we have a 3 kg object, and right now it has some weight. And in the opposite direction, there's also the tension from the string. So we have the weight, and then we have the tension. If the object is accelerating downward, this tells us that the weight must be greater than the tension, right? Otherwise, there would be no acceleration. So the weight is greater than the tension, thus there would be a resultant force acting on this object. So resultant force is going to be the weight minus the tension, because right now the weight overpowers the tension, and so there is a resultant force of some value acting on this 3 kg object. And since the Newton's second law is telling us that the acceleration of an object is directly proportional to the amount of force applied, so if there is a resultant force acting on this 3 kg object, this 3 kg object will experience an acceleration. So we can just set up an equation, F is equals to m times a. So simply put, we have W minus T, the resultant force, is equals to the 3 kg mass multiplied by the acceleration. So let's plug in the values. So right now the mass is 3 kg, and the acceleration is 4 meters per second squared. Plug the numbers in. We have 3 kg times 10 minus the tension is equals to 3 kg times the acceleration of 4 meters per second squared. Tidy things up, so we have 30 newtons minus the tension, and this is going to equal to 12 newtons. So the tension, solving for T is simply going to be 30 minus 12, or 18 newtons. I hope that helps.